Welcome back, mathematicians. We have been learning so many different ways to solve problems. We have been learning about how to solve different types of word problems. Today, we are going to continue with our learning with another type of word problem. Let's go ahead and look at our learning target today. Our learning target today says, I can solve word problems with unknowns by using a model and an equation. We should be really good at that because we have been using models and equations to help us solve for a really long time. Today, we're going to see a different type of word problem. Remember, when we see these word problems, we always want to check to make sure we're solving for the right thing. Make sure you listen for those clues to give you a hint. Let's go ahead and look at our first one. Our first one says, Corey has some cookies. Topanga ate 7. Now he has 5 left. How many cookies did Corey have to begin with? Let's think carefully about our clues. Corey had some cookies. Topanga ate 7. Now he has 5 left. How many did he begin with? Do you see some clues that could help you to solve this problem? Let's go ahead and dive in. Corey has some cookies. Do we know how many Corey has? No, so we have that word some. We always put a box around the sum. Corey has some cookies. Topanga ate 7 of them. So if she ate 7, what does that tell you that we're going to need to do in this problem? If there were some cookies and she ate 7. That's right, we're going to minus 7 because she ate them. They aren't there anymore. Now he has 5 left. So we had some, Topanga ate 7, now we have 5 left. Let's go ahead and set up our problem. We had some cookies, Topanga ate 7, and now we have 5. So this problem looks a little different from our last set of problems. Something minus 7 equals 5. Let's think about this. I know that when I start a subtraction problem, that my largest number or my whole is always first. So I know that this must be my whole. I know my whole can minus a part to get to the other part. So I'm trying to solve for my whole. Last time we were together, we were solving for a part. This time, we're solving for our whole. If something minus 7 equals 5, then you can put your two parts together to find out what your whole was. So I could say 5 plus 7 equals box, because my part plus a part can equal my whole. If something minus 7 equals 5, then I can think backwards. 5 plus 7 will equal my whole. So my addition and subtraction can work together to help me solve. On your paper, I want you to use a model or a strategy that will help you solve for the whole. Press pause, and when you're ready, hit play. Wow, I heard a lot of great thinking. So one way that we could always start with is a part-part whole since we are trying to figure out what that might be. So I'm going to start off using a part-part whole. I know one of my parts is a 5. I know the other part is a 7. What I need to know is what my whole is. So if I have 5, I can add 7 more. Count with me. 1, 2, 3, 4, 5, 6, 7. Now I can go back and count on 5, 6, 7, 8, 9, 10, 11, 12. So my whole would be 12. 5 plus 7 equals 12. And I could write the turnaround fact, 7 plus 5 equals 12. I could use my subtraction to help me as well. 12 minus 7 leaves me with 5. So how many did Corey end with or begin with? He started with 12. Then Topanga ate 7, and now he has 5 left. I could also try this with counters. I know that I have 5. I add 7 more. 5, 6, 7, 8, 9, 10, 11, 12. And my answer is still 12. On a number line, I could still show my thinking. I know that I had some and I ate 7. Now I have 5. But I also know these are my 2 parts that I need to figure out. So I'm going to start at 5 and I'm going to add 7 instead of subtract. 1, 2, 3, 4, 5, 6, 7. Because 5 plus 7 would give me 12. When you have these types of problems, think backwards. Something minus 7 equals 5, then 5 plus 7 equals 12. Let's try another one. There were some students on the playground. 9 students went inside to get water. Now there are 7 students left on the playground. How many students were on the playground to begin with? Think about what the problem is saying. There were some students on the playground. Do I know how many started there? No, because it said some. So I'm going to go ahead and put a box. 9 students went inside. So there were some and 9 students went inside. So am I going to be adding 9 more or subtracting 9? That's right, I'm going to be subtracting 9 because these 9 students went inside. Now there are 7. What equation could I write for this problem? Pause, and when you have your equation, hit play. Great thinking. So I had some. I minus 9. Now I have 7. Again, my whole always goes first in a subtraction. So this would be my whole. My parts are what we put together to make our whole. So these must be our parts. A whole minus a part gives me the other part. Do you remember what we talked about? What can you do now to help you solve what this first number is? That's right, you can put your parts together to make your whole. So if something minus 9 equals 7, then 7 plus 9 gives you your whole, because you can put your part and your other part together to make your whole. Go ahead and solve for what's missing in this problem. When you're ready, hit play. Great thinking, boys and girls. So I saw a lot of different kinds of models being used. I saw where someone started with 7 and they added 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 7 plus 9 is 16. I can check my work by thinking about this other problem. If 7 plus 9 equals 16, then 16 minus 9 should equal 7. So I'm going to go ahead and draw my 16. I'm going to minus 9. And we'll see if what we have left is 7. 1, 2, 3, 4, 5, 6, 7. So I just double checked my work. If I had 16 and a minus 9, it gives me 7. So 16 minus 9 equals 7. Great job, guys, thinking. Another model that you could have used could be a 10 frame. We start with our rectangle. We draw a line and slice it, and then 4 lines down. Now, I know one part is 9, so I'm going to go ahead and draw my 9. I know that now there are 7, so that must be my other part, so I'm going to draw 7. I always make sure to make my two numbers a different color so I can tell them apart. So now I know that I've made a group of 10. So 10, 11, 12, 13, 14, 15, 16. I can check my work again. If I have 16 and I minus 7, so 11 minus 7, will I get 9? So let's see. If I take away my 7, it leaves me with 9. So 16 minus 7 equals 9. Great job, mathematicians. Let's try one more. Make sure that you're looking for all of the clues before you try to draw your equation. De'Arion had some pennies. He gave 12 pennies to his brother. Now he has 4 pennies. How many pennies did De'Arion have to begin with? So let's think through our problem and look for our clues. De'Arion had some pennies. Do we know how many he started with? No. So I know that that's going to be my box. He gave 12 pennies to his brother. So what would I need to do here if he gave 12 away? That's right. I'm going to minus 12. Now he has 4 pennies left. So what equation would go with our thinking? If he had some, he gave 12 away, and now he has 4. Take a moment and write your equation on your paper. Hit play when you're ready. Great thinking, guys. So I had some. I'm not sure what that number is yet. He gave 12 away, so minus our 12 that he gave away, and now he has 4. So remember, anytime we're subtracting, our whole always is first. So we will be trying to find our whole. What the problem did give us was our 2 parts. If our whole minus a part equals the other part, then our part plus a part will give him a whole. So I'm going to think backwards. 4 plus 12 equals our whole, because our part and our other part can go together to equal our whole. Take a moment, use a model and strategy, and then hit play when you're ready. Great job, mathematicians. Something minus 12 equals 4. 4 plus 12 equals something. So we could start with our 4. We could add our 12 more. And then we could figure out what our whole is. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 4 plus 12 is 16. I can check my work. I can put my 16 . I can minus my 12. And I would have 4 left over. So is this right? Yes, that is correct. If 4 plus 12 equals 16, then 16 minus 12 equals 4. And we can use our subtraction and addition together to help us solve for the missing whole. I could have also used a number line to help me. I knew that she had 12 that she gave away, and I know that now they have 4, so I had 4 plus 12, but I can flip that around to be 12 plus 4 to get my whole, because a part and a part make a whole. So I'm going to start at 12. I'm going to add my 4. 1, 2, 3, 4. And now I know we started with 16. Great job, mathematicians, using your great skills that you've learned and thinking about those clues that we know to use when we're solving these type of problems. We have to think about, what is the problem asking us and telling us? Is it telling us our parts, or is it making us solve for our whole? Be careful to listen for those clues as you're reading these type of problems. You guys did a great job with meeting our learning target. Today, we learned how to solve different types of word problems with unknowns using a model and an equation. Great job, boys and girls. I will see you next time.